And welcome everybody to the Daily Space Weather. Too much stuff to talk about today. Lots of things going on, including Earth-facing coronal mass ejections. Don't say we didn't cover it. Don't say we didn't have a watch out for it for the last 4 days. Let's take a look at the sun directly to start things out. Don't look at the sun directly without the proper instruments, like our channel. Here's 304 angstroms, and you can see a bunch of filaments down here in the southeast quadrant. What the heck happened there? In the southeast quadrant down here. And we're trying to get a beat on exactly where that coronal mass ejection came from. I would have guessed it came from the north somewhere. So we are streaming live right now. Let's go look at what's going on from the viewpoint of Lagrange point 5 at stereo A. And there is the coronal mass ejection we're referring to. We're looking at a difference image here, and this is going to show you the highest speed portion of it in the brightest color. We see some pretty high speeds there from the view of stereo A. Some component of that is most likely Earth-facing. It looks majorly Earth-facing, actually. And I believe we are looking at halos on both the LASCO C2 and the LASCO C3, an indication that they're fully Earth-facing. So here's the C2 and here's the C3. We'll see what we see on those. That's too many C's. And it certainly looks like a halo, just emerging from behind the disk. Shouldn't be able to see very much on the C3. Alright, so it's just finally coming through there. You can see it a little bit on the C2. But by far the best view is from stereo A's perspective. There is the stereo A coronagraph. The difference image and again, for you new viewers, that's located out there at Lagrange point 5. So we'll talk about Bremsstrahlung a little later. Yes, Bremsstrahlung, it's a real thing. And when protons make it to this point, you get some serious Bremsstrahlung. We'll talk about it. These are the Van Allen belts, by the way, that you're looking at, and we're looking at altitudes of things like spacecraft. And of course, the inhabitants of the International Space Station are one of the primary concerns when it comes to Earth-facing coronal mass ejections. So they're not located at Lagrange point 1. They're not located anywhere near there. They're only about 230 miles up in a low Earth orbit. So they're within the inner Van Allen belt as well. In any case, let's move on to talk about the radio flux. The output of the solar corona is quite low, despite all the coronal mass ejections happening. So we see a radio flux here of the 10.7 centimeter variety at 75. So quite low conditions there, more like solar minimum conditions, and you can see how low that indeed is. 75 is all the way down here on the historic graph. And we did see it get into the 100 and teens briefly at the beginning of cycle 25. So you're just a little over a year, you're about 13 months into cycle 25, folks. And that's the radio flux there since 1947, when the 2800 megahertz solar radio flux was discovered by some Canadians. Shout out to all of our Canadian pals. Shout out to our Canadian friends and our Canadian foes. Don't really have any foes, folks, just kidding. All right, so here's 94 angstroms. We are kind of looking for a location of that coronal mass ejection. I still say it came from the north. Perhaps up in this area. It looks like a coronal hole opens there. From the way stereo A looked, it looked like the plasma was indeed in the northwest portion. So that could be a good candidate Or it could have been from this filament in the southeast, who knows. So here's a quick look at the fields. Again, no sunspots. No really organized magnetic regions, as you can see there on the magnetogram. And there's the fade to 171 angstroms and 304. Here's a video of about the past 24 hours. Again, we are streaming this live to get you the most current data. A reason why you need to subscribe to the channel and view the content when it comes out. I do see a little bit of brightening up there in the northwest. Not exactly sure. That coronal mass ejection released around probably something like about 3 o'clock. So here's another view. This is the 335 angstroms, another one of the ionized iron emission spectral wavelengths. And there's a bunch of different ionized states of iron on the surface of the sun. Did you know that? That there's a bunch of iron on the surface of the sun? Who knew? It gives us great insight into all kinds of features on the sun's surface, the chromosphere, and the corona. So let me just check the life of the stream here. We are good. And thanks to all the viewers who are viewing YouTube live premiere, viewing on BitChute, etc. Let's talk about our playlists. If you haven't checked out our playlists, youtube.com/smashamash/playlists is the place to be. You'll find Smash Lights, the Smash News Network, the official news network of the channel. You know, Smash News Network, least busted name in news. Well, we've got a new segment coming out called the Smash Hole of the Week. So if you've got ideas for this week's Smash Hole, I think we're going to actually change the spelling of the word to W-E-A-K. Smash Hole of the Week. W-E-A-K, the week. Yeah, so that way we won't be constrained to a weekly show. We can cover however many smash holes we need to cover. As sometimes there seems to be a plethora of smash holes. So we did a special last night, by the way, because of coronal mass ejections and coronal holes striking the Earth and geomagnetic unrest. Again, please press like and subscribe on YouTube if you enjoy the content. Tell your friends, your foes, your science noobs, your science pros, and everybody in between about the channel by sharing on your social media. Leave us a comment. Press the notification bell. And don't forget to press like. No, that's okay. We'll wait. You just subscribe, and we'll just wait around all day for you to press subscribe and like. The video can continue here at the Smash News Network until you do so. All right, so anyway, we've got all kinds of views of the coronal mass ejection that's been striking in the past 24 hours, as well as the coronal hole wind stream. Thanks to our BitChute users, look for a 300-plus subscriber exclusive coming to BitChute soon. BitChute.com/smashamash. Today we've got a cosmology segment. Oh, and once again, a reminder, don't forget to leave a comment. Let us know who you think the smash hole of the week is, as there is often quite a variety. Thanks to our patrons, who are not smash holes at all. Please consider becoming a patron at patreon.com/smashamash. And if you're paying us less than $3 per month, please upgrade to $3 or more per month, because you won't be getting any benefits unless you're at $3 or more per month. So thanks to all of our patrons regardless. Patreon.com/smashamash. Again, we do have a video coming out about coronal holes. It's all in the works. And we'll be talking about the current sheet and a little bit of the cosmology associated with coronal holes as well during that video. We'll have a guest host, and who it is shall have to remain classified. And I think I pressed the wrong button there. By the way, there's a coronal hole history page at solon.info. Go check that out if you like. solon.info/solar contains a link to this page here. And I believe the coronal hole that is currently geo-effective is actually this one here. number 986, the northern one. We'll be looking for some geo effects of this southern one, which was trans-equatorial also, by the way. Today we're not rolling any dice to figure out which object to cover. We're just going to cover Cygnus X3, which you're viewing it right now on Chandra, which is an X-ray telescope. And the interesting thing that's noteworthy about Cygnus X3 is that you're looking down directly a poloidal field jet. That's why this is the brightest intrinsic object in the Milky Way galaxy. So from the view of our solar system, the star in the sky Deneb, part of the summer triangle, it's actually much farther away than a lot of stars that appear brighter in the sky. This is the brightest intrinsic object visible from Earth. And it all has to do with the orientation. So this is a known cosmic ray point source as well. It's quite an interesting object, to say the least. If you want to read lots of stuff about it, head to smashomash.com/forum. Here, I'll show you how to do it. If you just type in smashomash.com or smashomash.org, you'll end up on our homepage, which shows all of our social media. Just click on this arrow in the upper right. And also a link to the smAsho forum and the smAsho stores. So pick up some merch at the stores. Head to the forum if you like. One of the forums is a cosmology forum. And we haven't been doing a lot there because I'm too busy. I'm extremely underpaid and overworked. Anyway, there's a whole thread there about Cygnus X3 massive X-ray binary celestial pole star Deneb. And it's quite interesting, to say the least. So go have a read about one of the only known cosmic ray point sources, the star to which Göbekli Tepe appears to be aligned. Maybe that'll spark your interest. Here's X3 on the 2-mass infrared light. And I believe what you're seeing there is actually part of the jet. I think what you're seeing is, this is the portion of the jet that's oriented away from you, and this is the point of the jet that's oriented toward you. So it's quite interesting indeed. Here it is again on the Chandra, which is only going to show you X-ray. And you can see the toroidal shape around this. And you know, this is, you're looking down a poloidal field here. And this object is able to send protons all the way into the surface of the Earth. Believe it or not, it just happens to be true. I don't know how else to explain it. If you want to follow the X-ray output of Cygnus X3, it's actually reached around what appears to possibly be the peak of its current activity right around New Year. So you see it got into this very stable mode right here at the end of this. That's kind of at the top of Cygnus X3's normal range. So that's the X-ray transient output of X3. And the interesting thing about X3 is that this object orbits a Wolf-Rayet star at a period of 4.8 hours. So it's traveling at relativistic speeds. And that's why we see the jet turn off and on every 4.8 hours. It's a bit strange. But in any case, if you read papers about X3, and we have them linked on the website, you may find it even stranger. So, yeah. So perhaps have a read about that. That's today's cosmology segment. And let's move on to some more current data as we're in a state of geomagnetic unrest as Bremsstrahlung occurs in the geospace. And that's part of the reason why we tell you not to be scared of CERN, folks. Because if you're worried about CERN, you obviously have no idea what's going on in space. And in space regularly, the coronal hole, wind streams, and so on create a situation with relativistic speed interactions happening right above your head, which is why CERN's not going to open a, quote, black hole, end quote, or cause the Earth to enter into a hell dimension. It's just not going to be a thing. So you should stop worrying about CERN. And no, CERN is not causing sunspots to form, if you're wondering about that. So the current solar wind speed is off of its highs, which made it all the way up to about 630 kilometers a second, now down to about 550 kilometers a second. Solar wind density still elevated here at 8.1, And it made it all the way to 50 last night at the beginning of the coronal hole wind stream. So that was the leading edge of the coronal hole wind stream, made it up to 50 protons per cubic centimeter, but then promptly simmered down to a low of 3.2. And now it's come back up again a little bit here, again around 7 protons per cubic centimeter, and a speed of 553 kilometers per second, which is pretty quick. Let me close that coronal hole stream. And again, what I'm talking about when I say Bremsstrahlung is a term which is pretty much just a German term. And, oops.
Bremsstrahlung.
And Bremsstrahlung is a term that means the braking radiation, the deceleration radiation that occurs, usually from an electron. When a proton makes it to the Van Allen belt, there are all kinds of funky things that happen in space. You create ionization pathways, and plasma aligns to magnetic fields, and current is produced, and all kinds of radiation is produced. And the Bremsstrahlung is literally the radiation coming from those. In other words, that's what they're measuring inside of CERN, is the braking radiation. And we see this coming out of things like the poloidal fields. I think I've done a callback there. By the way, we'll be featuring information from the Tromo Geophysical Observatory in the future. Let's get back to current data. Geomagnetic unrest is a thing. And let me just check the life of the stream here. Again, thanks everybody for tuning in, whether you viewed live or you viewed Memorex. You probably viewed Memorex because I don't see any viewers, but I don't really have time to check. So in any case, that's what's going on with the KP index, a measurement of global geomagnetism. And we've gone back into geomagnetic unrest. It looks like NOAA may have slightly over-forecasted the geomagnetic storm here, as we haven't reached level 5 yet, and I'm not so sure that we will. In any case, here's an animation based on the space weather modeling framework. It's a model showing you what's likely happening with the density. And we'll see some striations here in the density in the past 4 hours, which is what's displayed on the Geospace Magnetosphere movies. And yes, I've got cocoa and cayenne pepper in my coffee. Anyway, that's 4 hours of data on density in protons per cubic centimeter. Low shown in white, high shown in blue. Here's the pressure in nanopascals. And this isn't that exciting of a model, really, because it just shows you between 0 and 1.5 nanopascals. And it's showing you several Earth diameters there of what's likely happening in the geospace. And by the way, if you want to learn more about this, click on Details and click on Space Weather Modeling Framework, and you'll find all the information about that. It's quite a complex series of data points, including all kinds of magnetometers, space and ground-based, the electron flux, Van Allen probes, and so on. Here are ground magnetic perturbations. This is a different model of the same data set, essentially, looking at what likely is going on the ground in terms of changes in the Earth's B field. It also gives you an idea of where auroras will be, and we'll show you the aurora forecast as well, as we see increased auroral activity over places like Alaska. Shout out to our viewer, Brett, our viewer and I believe patron. And right now we see the major perturbations here over places like southern Greenland and the northern Canadian pole, not the northern Siberian pole. More changes in the Earth's B field over Canada than over Siberia, despite there being a pole in both locations. I'll let it play through a second time here. You're unlikely to see auroras there in the southern hemisphere, unless you're on the Antarctic continent. But we should be seeing significant aurorae there over places like, well, by the time the video is going on, over Alaska. But central Canada and so on, Iceland and Greenland should have had great nights for aurorae. And here's that model. The 30-minute aurora forecast. Let me blow that up a little bigger. There we go. We did see a significant uptick here over Alaska here at the end of the forecast. We'll let that play through. There's a bit of an uptick. And then a shutdown. So here's the proton flux over the past 3 days. We don't see any proton strikes yet. And we could from that coronal mass ejection. Sometimes it takes only a half an hour for some of those protons to show up, folks. So yeah, we'll be keeping an eye on that. And when I say ion, now for those of you not aware, the coronal mass ejection is primarily composed of hydrogen nuclei, which are highly charged particles which violently steal electrons when they show up. They violently steal electrons, which causes Bremsstrahlung to happen. And once again, a prime example here, looking at the 3-day X-ray flux chart. And we stress this regularly here at the smAsho News Network, that you don't need sunspots or solar flares to see coronal mass ejections. So here we see all kinds of spikiness going on in the GOES magnetometer. And the GOES 16 measures the magnetism at the F ionosphere layer. So we'll show you a diagram of that momentarily. First, we're going to show you more magnetic data. And you can see that arc jet moment there where the spacecraft turned on its engines and it created its own plasma and ionization pathways, which could have thrown off the measurements, which is why they show that part in yellow. And it's not surprising to see this sort of all over the place here with a coronal mass ejection and a coronal hole striking at the same time. So here's a view of the heliospheric current sheet, the likely polarity here with the top view ecliptic plane field plot. We see a bit of North Pole current sheet coming through there. So expect to see continued striations here in this. Normally this is a little bit more smooth. And for you new viewers, that's midnight and that's noontime, local time for the GOES 16. Here's a line of sight coronal hole field plot, and you can see that trans-equatorial South Pole oriented coronal hole that we talked about earlier on the solon.info link, solon.info/solar, for lots of information about what's currently going on. So here's another line of sight field plot. It also shows you the solar magnetogram. And indeed, I like my coffee so hot that it causes a religious experience. I like my food so spicy that I prefer to see a deity and say, oh my God, it's so hot I've got to reference a deity. Here's what's going on in the coronal magnetic field area. The magnetic field environment of the sun's atmosphere, known as the corona. No comment there, except that's a chaotic place. Speaking of chaotic places, I like to look up in the sky sometimes. And when I do, I like to know what's up there, so I use in-the-sky.org. We're not paid to say it. And there should be a view of the moon if you're located where I am, which is in eastern Pennsylvania, by the way, Lehigh Valley. And here's what's going on in the solar system. There's where things will be in a week. And the 13th will be a new moon, my favorite phase. And beware of this equilateral, this roughly isosceles triangle here forming between Jupiter, Uranus, and the Earth. Know the distinction between Uranus and a hole in the ground, and that Doritos and Frito-Lay are trying to take over the solar system. It's part of the reason why there's a Space Force. The Space Force was created to fight back against Frito-Lay, who wants to provide Doritos for the Galactic Federation. We can't have that. Let's talk electrons. We've got some charging hazards happening right now. And here at the Smash News Network, we prefer for you to know about it. So here's where you see some charging hazards. Some surface charging happening around Central America, Mexico, even southern Florida, and northern South America. Points north of the equator. Here's a one-year chart of the electron flux, and we're at pretty low levels here. Fairly normal levels, and expect a big uptick here after the coronal Holt wind stream subsides. We'll get up here into warning levels most likely. The green boxes are showing, the green boxes are showing you the forecast, and the yellow diamonds are showing you the observation. So here's the 3-day chart. We briefly got into warning levels yesterday. And here's a visualization of the electron content. And we see anomalous electron content here. Over both North America and Antarctica. We see big electron flux anomalies. So right here, significant GPS errors happening in places like the east coast of the US. And you can see a constant flux here over Antarctica. And next we're just showing you a diagram before I vanish. Here's a diagram of the atmosphere showing you the troposphere, which is where your weather occurs. The stratosphere, which is where people think planes are spraying chemicals in order to dim out the sun. And then you've got things like the ionosphere, which is what we're looking at next. And here's the F layer. That is around 300 kilometers. That is where the GOES 16 makes its measurements. And here's a visualization, and the ionosphere is looking quite anomalous here. So we don't always see oddities in the ionosphere during geomagnetic storms, but this time we certainly do. And there you can see, we've been seeing continued charge-ups here over the past couple of days. Perhaps there's predictive value in looking at the ionosphere. If there is, we'll let you know as we look at it daily. And let's bring up the latest image here. Latest image coming at you from 9:45 Universal Time. And you can see portions of the southern hemisphere remaining charged despite the sun being way up here. So that's, in a nutshell, what's going on with that. Let's look at volcanoes. There's a whole bunch erupting. Kluchaskoy, Abico, Kadavar, Dakono. They're all erupting, producing between 6,000 and 23,000 foot ash plumes. Popocatépetl down in Mexico also exploding, as well as Fuego, and Sangre, and Sabancaya. Big ash plumes over all of those between 15 and 26,000 feet. Please don't pole vault the caldera. And if you're wondering, Popocatépetl is absolutely on my bucket list. I so want to visit Popocatépetl. We did see one 6+ magnitude earthquake here in the Kermadec Islands region over the past 24. Not at depth. So let's see if the deep earthquakes have subsided. We've reported on quite a few of them in the past couple of days. Here's a 4.6 at just over 100 kilometers at Chile. A deep quake under Denali National Park, a 4.0 magnitude at 160 kilometers. That's the largest deep quake I think we've ever reported on under Alaska. A 4.0 under Denali. Check the location of that. Is that a super volcano, folks? Are you seeing this circular crater-like area? Just saying. I mean, I have no idea. I'm just conjecturing here. Anyway, that's the location of that. Right at the northern portion of the Alaska Range, the Northwest Alaska Range. Small deep quake in the Dominican Republic. And there's that 6.2. That came in at 6:20. 6:20, the striking of that 6.2 magnitude quake. And by the way, at nullschool.net, you can get a real-time space view. So here's what's going on in the southern hemisphere as far as the aurora australis, not likely visible from New Zealand or from Australia. But in the north, significant chance of people in especially northern Alaska, northwestern Canada, of getting a view of the aurora currently going on. And it looks like the solar wind is subsiding a bit. Let's look at the jet streams as we do daily before we get into other meteorology stuff. So here are the jet streams of the western world, and talk about meridional jet stream flow. Check out this bend. Sending some cold air directly from Canada on an express train to Texas. And we've got tripled up jet streams here over the northern hemisphere. It is chaotic. Southern hemisphere also all broken up. Here is the eastern world's jet stream scenario. Let's talk more meteorology. We see some lightning in the Atlantic. Let's see what's going on in the real-time lightning map. I like to use lightningmaps.org. The official lightning map of Thor and Odin. This segment brought to you by Thor and Odin, who remind you to be a good Viking and check out that sudden strike. Be a good Viking and make sure you go to Valhalla or something. Make sure you create a waterborne funeral pyre and send corpses flaming into the ocean or something. Sounds pretty cool. Wait until the tide's going out or Thor's going to be mad and he's going to create thunder in your pants. Mr. Thunderpants. Is your nickname Mr. Thunderpants? Leave us a comment. So we've got a bunch of wintry conditions here over the central northern portion of the country, like Minnesota and the Dakotas. A bunch of rain and snow showers in the northwest, and continued snow showers over places like western Pennsylvania, State College area, and so on, the most mountainous part of the state. And check out this low south of Alaska. Yowzers. That is a serious low. And perhaps a big risk for large earthquakes there. Let's let this advance. Check it out. It's going to stagnate there, according to the GFS forecast. It's going to stagnate and rotate south of Alaska. Although it looks like it's also going to weaken. I would be on high alert for earthquakes, folks. Proton flux, earthquakes, coronal mass ejections, record-breaking low-pressure systems. The strongest low-pressure system in the world It's just going to hang out there. And Alaska is the site of the largest quake we've seen in the past, in the past year, I guess I'll say. And let's check out what's going on in the cloud layer over the lower 48. Right after I vanish. And a bunch of low clouds once again over the Atlantic. Here's what's going on in water vapor. Bunch of moisture creeping into northwestern Montana. And there's no need to zoom in today. We've got bonus features, though, as we do most days. It'll include the colorized magnetogram, the intensitygram, to show you 0 sunspots. And we'll make sure we have the latest high-res image here at the smAsho News Network. Least busted name in news. You know why that is? It's because I don't have an agenda and I don't talk nonsense. Isn't that refreshing? Anyway, there's the colorized magnetogram. And again, 0 sunspots. There's the intensitygram. I don't see any sunspots, do you? We're going to go back and show you stereo A. Once again here, we're going to bring up the latest difference image. I think. All right, here we go. There's the latest footage of that coronal mass ejection, which I would say most assuredly is going to have some Earth-facing portion. It's still not fully ejected yet. And we'll check and see if there's anything new on the LASCO here. Real quick, we'll bring up the C2 and see if that looks like it's a continuing halo. Really only the last couple of frames there are relevant. I don't see any coming out of the south part of the disk, only the north part. So it could be a situation of missing to the north, but the way that really looks to me is that that's going to be definitely partially Earth-facing and somehow geo-effective there. The Earth is off in this plane, almost straight perpendicular to the solar equator. And we'll show you the rest of our HelioViewer movies to close things out, including, of course, the 304 and 193 angstroms. Gotta have them. As the 193 shown here will show you coronal holes like that Earth-facing one, which is sending some protons your way already. So expect those in about 3 days, and expect lots of updates here, as there are some from a coronal mass ejection on the way, some of which could be moving at quite a high speed. And expect that coronal mass ejecta to arrive in 2 to 3 days as well. So we'll have more geo-effective matters at hand. Condensed matter matters. Great view of that coronal hole there. We got to do a close-up of that later. But we don't want the video to be too long. So here's 304 angstroms. This will probably show you the coronal mass ejection. Again, that let loose around 3 or 4 universal time, 03 or 0400, somewhere around there. And I really thought it would have come out of the north somewhere, and I can't see it, and I don't really have time to worry about it. So in any case, thanks for tuning in, folks. Remember, stare at the sun, don't drink, no matter how much the government drives you to do so. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back. I've been told by our producer to rewrite the ending. Eyes, no. Open, fear. Wait. Eyes, no. Fear, open. Open eyes, fear, no? Open eyes, fear, no?